Imagine walking into a courtroom, right? You're facing a really serious criminal charge, and your defense attorney, they don't even bother to cite legal precedents. Instead, they just roll out a chalkboard and start writing out equations from theoretical physics, network topology, and like distributed computing theories.
Yeah, I mean, you would probably think you were watching some kind of sci-fi legal drama.
Uh-huh.
Because when a person's freedom is on the line, we expect a defense to hinge on, human intent or maybe a misinterpretation of the law.
Right, or like a procedural error by the police or something.
Exactly. We absolutely do not expect an argument based on the laws of thermodynamics.
But surprisingly, that is the exact reality we are looking at in today's deep dive. We've got our hands on a translated 40-page legal defense manifesto, and it was actually written from a jail cell.
Oh, wow.
Yeah. The author is a Dr. Chen-Jing Yuan. He was formally charged with the crime of, quote, picking quarrels and provoking trouble. The authorities explicitly accused him of causing severe public order disruption, and his alleged weapon, a single retweet.
Literally just forwarding a piece of information online.
Just forwarding a post on a social media platform, that's it.
And instead of arguing over the content of that specific retweet, or just pleading ignorance, Dr. Chen took a route I have, frankly, never seen before. He applied complex network science and the CAP theorem to mathematically prove that the judicial system's whole linear cause and effect argument is a physical impossibility.
I mean, that is just wild.
Right. His defense wasn't, I didn't mean to do it. His defense was the foundational physics of the internet dictate that I fundamentally could not have done it.
So for you, the listener, whether your background is in law or computer science, or you're just curious about how information actually flows in the digital age, this deep dive is going to completely change how you view your own footprint on social media.
It totally forces a shift in perspective. You have to move away from human behavior and look at systemic architecture. So, to really grasp Dr. Chen's defense, we have to start where his manifesto starts, which is the baseline reality of the internet itself.
Right.
The prosecution claimed his retweet caused disorder, but Dr. Chen counters by asking, well, what does order even mean when you're dealing with a global digital network?
Okay, let's unpack this, because usually when we think of a network functioning properly, we assume order means perfect synchronization, right? Everyone seeing the same information at the exact same time, like everything is in its proper place.
Yeah, that's the intuitive human assumption. And it's also, crucially, the assumption the legal system makes. But mathematically, in distributed systems, it's entirely incorrect. Dr. Chen points to this foundational rule of computer science called the CAP theorem. It was proposed by Eric Brewer back in 2000.
And CAP stands for consistency, availability, and partition tolerance.
Exactly.
And a system can only have two of those three, right? Like you have to pick two.
Precisely. The theorem mathematically proves that a distributed data system cannot simultaneously guarantee all three. Consistency means every single node, or user, sees the exact same data at the exact same microsecond.
Which is hard to do globally.
Very hard. Availability means the system always responds to a request, no matter what. And partition tolerance means the system survives and just keeps operating even if some network connections drop or, servers fail.
Well, since modern social networks are global, network drops and latency are just physical realities. Signals literally have to cross oceans. So partition tolerance isn't optional. I mean, it's mandatory.
It is entirely mandatory, and these platforms are fundamentally built to keep you scrolling and posting 24/7. So they absolutely must prioritize availability. And if they prioritize availability and partition tolerance,
they have to drop consistency.
Exactly. The unyielding laws of computer science dictate they must sacrifice absolute consistency.
Meaning that, at the data packet level, asynchronous states are just baked into the code. I might see a totally different timeline than you do, or a post might take time to propagate across different global servers. The system is inherently mismatched at any given microsecond.
That is the crucial takeaway here. Inconsistency is not a bug. It is a structural necessity for the internet to even function. Therefore, Dr. Chen argues, inconsistency or disorder is a physical constant of social networks. It's the baseline operating state.
I'm picturing an ocean. If you accuse a single user of causing chaos on a social network, it's like throwing a tiny pebble into a stormy sea and then being blamed for the waves. The waves, the turbulence, the inconsistency, that's just the natural physical state of the ocean. They exist completely regardless of the pebble.
The ocean analogy is incredibly accurate here. The system is literally designed to be chaotic. So the prosecution took a baseline physical property of the network, its inherent inconsistency, and treated it as a criminal outcome generated by one person. Dr. Chen identifies this as a fundamental category error by the court.
But if the baseline is just this chaotic, inconsistent ocean, how does information ever travel effectively? I mean, things obviously do go viral. There has to be some kind of structural highway system beneath that chaos that allows data to flow, right?
Right, and that underlying structure is exactly where Dr. Chen goes next. He transitions from the system's baseline state to its topological structure. Specifically, he uses the Barabasi-Albert model, focusing on what are known as scale-free networks.
Now, most human infrastructure we interact with doesn't operate like a scale-free network. If you look at, say, a highway system, it's somewhat evenly distributed. You don't have one city with 10 million highways and the next city over with 0.
Yeah, because that's a normal distribution. But the internet, and social media specifically, develops through a process called preferential attachment. It's basically the rich get richer.
Oh, I see.
This results in a power law degree distribution. In this mathematical model, the network is intensely heterogeneous. You have a microscopic fraction of nodes called hubs-think mega-influencers, massive media outlets, state-run accounts, and they hold a disproportionate massive number of connections.
We're talking tens of millions of followers.
Oh, easily. And on the complete opposite end of the spectrum, you have the vast, overwhelming majority of everyday users who function as edge nodes. They have an infinitesimal number of connections. In a scale-free network, the structural integrity and the flow of the entire system are determined almost exclusively by those hubs.
So Dr. Chen looked at his own statistical footprint, right? The manifesto notes his account had fewer than 100 followers.
Right.
And most of those were inactive, like what developers call zombie accounts. Historically, his posts generated 0 interactions. So, mathematically speaking, he is the ultimate edge node.
Which means his structural influence on the network literally approaches absolute 0.
Okay, I have to push back on the absolute nature of that claim, though. Even if his structural influence approaches 0 statistically, isn't that just an average? Couldn't one lucky edge node theoretically trigger a massive viral trend? We've all heard of the butterfly effect, right? A butterfly flaps its wings in Brazil and sets off a tornado in Texas. Why couldn't his one retweet do that butterfly?
That is a great point, and it's the exact counterargument the prosecution basically relies on. This idea of the unpredictability of viral content. But Dr. Chen actually anticipates this by analyzing network robustness. To address the butterfly effect, we have to look at how much damage or influence a scale-free network can actually absorb. For this, he introduces the Cohen-Haviland critical threshold formula.
I am kind of stuck on the math here, though. If the network relies entirely on hubs, shouldn't it be incredibly fragile? Like, if I take out just a few major influencers, doesn't the whole thing break?
It does, and that is the dual nature of scale-free networks discovered by physicist Reuven Cohen. They are extremely vulnerable to targeted attacks. If you deliberately remove the hubs, the network fractures into isolated islands almost immediately.
Wow, okay.
However, conversely, they possess almost unbelievable robustness against random failures or activities at the edge.
How does the formula actually prove that robustness?
Well, to understand this, we have to look at what statisticians call the second moment of the degree distribution.
Which is what exactly? Like the variance in connections?
Precisely the variance. In a normal system, the difference between the most connected and least connected person is relatively small. But in a scale-free network, because a hub might have 100 million connections and an edge node basically has 0, the variance is so massive it mathematically approaches infinity.
Oh, wow.
And because the second moment is so large, the Cohen-Haviland critical threshold, which is denoted mathematically as P sub c, approaches 1.
Meaning the threshold for collapse is incredibly high.
It means you would have to remove or alter nearly 100% of all edge nodes simultaneously to make the network structure collapse. A random disturbance at the edge gets absorbed instantly because the mathematical variance is just too wide for a tiny node to register. The system's architecture inherently dampens the noise.
So what does this all mean? To bring it back to a physical structure, it's kind of like a giant oak tree. If you take an axe to the trunk, which is the hub, the whole tree comes crashing down. But snipping one single leaf, an edge node, does literally nothing to the structural integrity of the tree. The tree doesn't even feel it.
Exactly.
And the prosecution is essentially claiming that Dr. Chen snipped a single leaf, and that act caused the entire massive tree to fall over.
That is the core of his topological argument. If completely deleting him and every other edge node wouldn't affect the network structure, his single retweet fundamentally cannot cause a structural collapse of public order. The physics of the network simply do not allow it.
Because it's not a linear system.
Right. The butterfly effect requires a highly unstable linear mechanical system. A robust, scale-free network is expressly designed to swallow butterflies whole.
Okay, the structural argument is ironclad. But what about the spread of the specific information he retweeted? Let's say the tree doesn't fall down, but could the leaf he dropped carry some kind of disease that spreads to the whole forest? How do we measure the actual physical spread of that specific retweet once it enters the network?
This is where Dr. Chen transitions from network topology to information dynamics. He needs to prove not just his lack of structural power, but his lack of infectious power. So to answer this, he relies on the Galton-Watson branching process.
This sounds really similar to epidemiology models used during viral outbreaks.
It is the exact same underlying math. The Galton-Watson process calculates the probability of a lineage, or in this case a cascade of information, surviving or dying out over time. In epidemiology, you hear this referred to as the basic reproduction number, or R0, which is the mean offspring number.
Right, we heard a lot about R0 a few years ago.
Exactly. For a virus or viral tweet to sustain a cascade through a population, the R0 must be strictly greater than 1. Every person who sees it must pass it on to, on average, more than one other person.
Anything above 1 is a supercritical state. It grows exponentially. And anything below 1 is subcritical, and it inevitably just burns itself out.
Exactly. So Dr. Chen calculates his own physical R0. We've established he has about 100 followers. The manifesto estimates roughly 15% are actually active online at any given time.
Okay.
If we generously assume a 1% probability that an active follower will actually see the post on their timeline and choose to retweet it, his R0 calculates to a minuscule 0.12.
Oh my gosh, that places him deep in the subcritical zone.
Deep subcritical. According to the Galton-Watson extinction theorem, if your R0 is 0.12, the probability of the information cascade dying out is practically 100%. Furthermore, you can actually calculate the expected total cascade size, like the ultimate number of retweets generated by his initial action.
What does that come out to?
It comes out to roughly 1.11.
Wait, 1.11. So he retweets it, which accounts for the 1, and statistically there is an 11% chance one other person does. But essentially, it stops cold with him. The data just reaches a total dead end.
The mathematical reality is unforgiving. The cascade dies in a vacuum. Now, Dr. Chen contrasts this theoretical physics reality with the actual judicial standard used to charge him. The Supreme People's Court guidelines in his jurisdiction define a serious disruption of public order involving online information as requiring 500 or more forwards, or 5,000 or more views.
Wait, the legal threshold demands 500 forwards, and his mathematically proven physical capacity is 1.11. He is off by a magnitude of almost 500.
Yes. The prosecution's phrasing requires a direct cause and effect relationship. They assert you did X, which caused Y. Dr. Chen uses the Galton-Watson theorem to demonstrate that his X causing their Y is an event with a mathematical probability of 0.
Here's where it gets really interesting. The brilliance of this defense isn't just a claim of innocence. He is exposing a massive disconnect in how human systems assign blame. He isn't saying, I didn't mean to cause chaos. He is arguing, I lack the physical properties required to cause chaos.
Which brings up an unavoidable counter question, right? If the edge node is mathematically incapable of causing the avalanche, what actually does cause systemic collapses in social order? Because crises do happen, things do go viral, and public order does get disrupted.
Yeah. But before we get into that, I should pause here and just remind you, the listener, that this translated manifesto is obviously a highly charged document. It features a private citizen directly challenging the logic of state organs. So I want to be really clear that we are not taking a stance on the politics of his specific legal battles here or endorsing any criticisms of the authorities. The theoretical physics arguments he uses to make his case are entirely objective, and that is strictly what we're analyzing today.
A vital distinction to make. So to answer what actually causes the collapse, Dr. Chen points to the concept of self-organized criticality, or SOC. And the most famous model for understanding SOC was created by the physicist Per Bach. It's known as the sandpile model.
Oh, I've heard of this. I can visualize dropping grains of sand onto a flat surface just one by one. Over time, it forms a pile, and as the pile gets steeper, it inevitably reaches this critical state where it's highly unstable. If you drop just one more grain of sand, it triggers a massive avalanche that collapses the whole structure.
That is the physical mechanism, yes. But the core insight of self-organized criticality is understanding causation. The avalanche wasn't actually caused by that specific final grain of sand.
Oh, wait, really? It wasn't?
No. That single grain is physically identical to the thousands of grains that came before it, none of which caused a collapse. The avalanche was caused by the systemic instability of the entire pile. For a single grain to trigger an event, the entire system must already be in an incredibly precarious supercritical state.
So Dr. Chen is arguing a complete reversal of the burden of proof.
Yes, exactly. He asserts that to legitimately convict him of causing social chaos with one retweet, the prosecution must mathematically prove two separate things. First, they must prove the entire internet architecture was already in a precarious, supercritical state. And second, they must prove his specific tweet was the exact, singular trigger that pushed it over the edge.
Which, as we just established with his subcritical R0 of 0.12, is statistically impossible.
Because when he drops his grain of sand, he is dropping it on the flat floor, nowhere near the peak of an unstable pile.
That makes total sense.
Precisely. And this leads to his most aggressive theoretical assertion. If the edge node is just a harmless grain of sand, who builds the unstable pile? Who actually creates the systemic risk? Dr. Chen's manifesto argues that the systemic dynamite is actually generated by the hubs.
The nodes with all the power, the connections, and the massive variance we talked about earlier.
Yes. In network thermodynamics, you look at entropy, which is essentially a measure of disorder or noise injected into a system. Dr. Chen argues that when massive hubs, such as authorities acting unjustly or judicial organs abusing their power, behave erratically, they introduce massive amounts of entropy into the network.
They're the ones steepening the sand pile.
They create the supercritical state. An edge node cannot create an avalanche. An edge node reacting is merely a microscopic reflection of a system that is already tearing itself apart from the top down.
The philosophical weight of that argument is just staggering. I mean, it highlights a gaping chasm between pre-modern legal phrasing and modern complex systems science. The law relies on deeply subjective human labels like picking quarrels or causing chaos. It's based entirely on human intuition. But modern digital reality operates on complex network science, which relies on quantifiable causal models, critical thresholds, and probability matrices. The legal system essentially says, we feel like you caused this. And Dr. Chen's defense says, show me the math.
It perfectly exposes the friction of trying to govern a 21st century digital architecture using 19th century mechanical logic. The legal system looks for a linear Newtonian cause, like A pushed B. But in a complex adaptive system, A is just a node reacting to a network of a billion other variables. Linear causation just doesn't exist in a scale-free network.
To summarize the absolute journey we have been on today, Dr. Chen Jingwan faced a criminal charge of disrupting public order. Instead of playing by traditional legal rules, he leveraged the CIP theorem to prove that inconsistency and disorder are the natural physical state of the internet. He used scale-free networks and the Cohen critical threshold to prove that as an edge node, he possessed zero structural power to break the system. Then, he utilized Galton-Watson extinction probabilities to show that his specific retweet mathematically could not spread. And finally, he used self-organized criticality to argue that systemic collapses are caused by powerful hubs injecting entropy into the system, not powerless edge nodes dropping grains of sand. He successfully translated a vague legal accusation into a falsifiable and ultimately debunked scientific hypothesis.
It is a breathtaking synthesis of scientific disciplines. And, it leaves us with a final provocative thought to ponder regarding the future of justice. As our societies become entirely digitized and our daily lives increasingly operate on these complex, nonlinear network physics, will our legal systems eventually be forced to abandon human juries and subjective judges?
What would an alternative even look like?
Imagine a future of algorithmic courts. Instead of legal causation being debated through rhetoric and human emotion, it is determined purely by running Monte Carlo simulations, like where a computer runs millions of randomized probability models of the network to see if an outcome is even statistically possible. Imagine a judge calculating R0 thresholds before a trial even begins to see if the alleged crime violates the laws of physics.
Wow. If the crime violates the laws of physics, the case is just dismissed before opening statements are even made. I love that. Well, I want to thank you for joining us on this custom-tailored deep dive today. Hopefully, the next time you drop a pebble into the stormy sea of your own social media feed, you will look at it a little differently. You are not causing the waves. You are just part of the ocean.